Good evening, Titans. This is Mr. Simpson, and we'll be studying lesson 7.6, which is factoring quadratic trinomials that have a leading coefficient in front of the x squared. First one we want to look at in this first example, and notice that the leading coefficient in front of the x squared is a 5. But what I want you to notice is that the 5 is common in all three terms. And so since the 5 is common in all three terms, we're going to treat it as a GCF. And we're going to put the 5 on the outside of the parentheses. And if we do that, now we have 5 times x squared plus 3x plus 2 when we divide the 5 out of each term. Well, now the leading coefficient in front of our x squared is a 1. So just like we learned today in class, we can just use the x method. And we know that the constant term of 2 goes there. The middle term coefficient goes there. And we're asking ourselves what factors of 2, meaning what multiplies to give me 2, but add to give me 3. Well, the factors of 2 are 1 and 2, so 1 and 2 multiply to give me 2 and add to give me 3. So now those are the numbers that we use in our binomials. So I have the 5 that's on the outside. Don't want to forget about that. And then remember, because it's just x squared, we have x and x. And we're going to have plus 1 and plus 2, and now we're done. And so number 1 is completely factored. The leading coefficient was a GCF, and what we were left with was a quadratic trinomial with a leading coefficient of 1. But if we look at example 2, in example 2, the leading coefficient of 2 is not common in all three terms. So now we can't factor it out as a GCF. So now we're going to use the x method, but we're also going to use what we call the x box method. And we use the x box today, but it becomes more important when that leading coefficient is not a 1. So to do this, we first take the product of a times c, which will end up equaling the m times n, meaning what factors multiply to give me that. And then the b is going to go here, which again is the m plus the n. We have the m and the n here. So in this particular problem, in our x method, 2 times 5 is 10. That's going to go there. So again, we take the 2 times the 5, and we get 10. The negative 7 goes here. Now we ask the question, what factors of 10, of a positive 10, add up to a negative 7? Well, that'd be a negative 2 and a negative 5. And now we use our box. And in our box, just like we've done before, the first term, okay, remember the first term goes here, which is 2x squared. The last term, which is going to go here, is a positive 5. And now these two terms with x's are going to go in these two boxes. So I'm going to put negative 2x here and negative 5x here. And remember, it does not matter which box you put those numbers in. And now we're going to use the GCF of this first row. And the GCF of this first row is x. And so if we factor an x out of each of those terms, what we have left, we're going to write up on top, is 2x minus 5. And now if we look at, remember, we have to multiply this 2x times this to give me negative 2x. Well, 2x times what gives me a negative 2x would be a negative 1. And now if I check that, negative 1 times this negative 5 is a positive 5. So now I have everything I need. Across the top, I have 2x minus 5. And down the side, I have x minus 1. And these are the two binomials that if I multiply them together would give me my original quadratic trinomial back. And that's called the x box method.